This is the 7th video on the physics quiz, a part of 25-part video series wherein we'll be discussing the basic fundamentals and concepts relating to various physical phenomena, famous scientists and other frequently asked questions in various exams. You'll find these videos besides the respective GK Today quiz under physics quiz section. Link is always in the description. Here we'll be talking about the satellites and their related concepts. If you have any doubts, feel free to ask them in the comment section. So now let's quickly get on with it. What do we call the minimum velocity with which a body must be projected up so as to enable it to just overcome the gravitational pull? Correct answer is C, escape velocity. So the minimum velocity with which a body must be projected up so as to enable it to just overcome the gravitational pull of the Earth, or for that matter any other planet, is known as the escape velocity and is given by VE is equal to square root of 2gr or 2gm upon r. So from the formula, the value of escape velocity depends upon the mass and the radius of the planet of the surface from which the body is to be projected. So clearly the values of escape velocity of a body will be different for different planets. What is the value of escape velocity for Earth? This is a very objective question. Correct answer is C, 11.2 km per second square. Always remember, the value of escape velocity is different for different planets. On which of the following the escape velocity of a body does not depend? We have already seen this. Your answer is A, mass of the body. Escape velocity is independent of the mass and the angle of projection of the body, but depends on the mass and radius of the planet from whose surface the body is to be projected. Which of the following condition will be true for a planet to have an atmosphere? Correct answer is A. A planet will have atmosphere if the velocity of the molecules in its atmosphere is lesser than the escape velocity. This is why Earth has atmosphere while Moon has no atmosphere. What is the height of geostationary satellites from the surface of the Earth? Answer is B. The satellite which appears stationary relative to Earth is called as geostationary satellite. A geostationary satellite always stays over the same place above the Earth. Such a satellite appears stationary due to its zero relative velocity, that is with respect to the place on the Earth. The height of geostationary satellite from the surface of the Earth is 36,000 km. The minimum speed required to put a satellite into a given orbit around the Earth is known as. Correct answer is B. So the minimum speed required to put a satellite into a given orbit around Earth is known as orbital velocity of the satellite. Orbital velocity is given by V is equal to square root of capital G capital M upon R square root, where G or the capital G is the gravitational constant, M is the mass of the Earth and R is the radius of the orbit of the satellite. An orbital velocity of a satellite does not depend on which of the following? Correct answer is D. So orbital velocity of a satellite does not depend on the mass of the satellite. It depends on the mass and the radius of the planet around which it is orbiting. Also, it depends on the radius of the orbit or the height of the satellite. Two satellites, A having mass of 500 kg and B having mass of 1200 kg. Both are launched from Earth. Which of these will have a greater orbital velocity if the radius of the orbit is same for both? Your answer is both satellites will have the same orbital velocity, as the orbital velocity of a satellite is independent of mass of the satellite. To understand this, we can also refer to the formula. V orbit, that is the velocity or the orbital velocity, is given by square root of capital G M, that is the mass of the Earth, upon radius R. What happens to the orbital velocity of a satellite when the radius of orbit is increased? Correct answer is it decreases. Why? Because in space, distance from the parent body currently being orbited is inversely proportional to orbital velocity according to one of Kepler's law. When radius of the orbit is decreased, orbital velocity increases, and vice versa is also true. Which of the following is the orbital velocity of a satellite orbiting very close to the surface of the Earth? Here it is better if you remember these numbers. Answer is 7.92 km per second. Again given by the same formula. In this case, the radius of the orbit will be nearly equal to the radius of the Earth, which is 6.38 into 10 raised to 6 meters or 6,378 kilometers. The time period of a satellite does not depend on which of the following. Correct answer is mass of the satellite. Time period of a satellite is time taken by a satellite to go once around the Earth. So this time period is independent of the mass of the orbiting body and depends on the mass of the central body. In this case, it can be Earth or any other planet, as well as the radius of its orbit. What is the time period for a satellite orbiting close to the surface of the Earth? Correct answer is 84.6 minutes. In this case, the radius of the orbit again will be nearly equal to the radius of the Earth. The time period for satellite orbiting close to the surface of the Earth, once you calculate, comes around 84.6 minutes. The angular momentum of a satellite depends on which of the following? Your answer is all of the above. If you look at the formula, the angular momentum of a satellite depends on the mass of the satellite, mass of the planet, radius of orbit of satellite, and it is denoted by L. Which of the following is an essential condition for geostationary satellite of Earth? Correct answer is all of the above. So the essential conditions for geostationary satellite of Earth, its sense of rotation should be same as that of the Earth. That is, it should rotate from west to east. It should be at a height of nearly 36,000 km above the equator. Its period of revolution should be around 24 hours. It should revolve in an orbit concentric and coplanar with the equatorial plane. Its orbital velocity is nearly 3.1 km per second. The kinetic energy of a satellite is maximum in which of the following conditions? Correct answer is A, when the satellite is at its perigee. That is, it is closest to the sun. So the kinetic energy will be maximum when the satellite is closest to the central body and minimum when it is farthest from the central body. In this case, the central body is the sun. Potential energy will be minimum when kinetic energy is maximum. That is, the satellite is closest to the central body. And maximum when kinetic energy is minimum. That is, the satellite is farthest from the central body. Water does not fall out of glass when it is inverted inside a satellite, which is orbiting very close to the Earth's surface. Which of the following is the best reason for this? Correct answer is C. The water and the glass have the same acceleration. The reason for this is that the water and the glass have the same acceleration due to gravity equal to g towards the center of the Earth. Hence, there is no relative motion between them. Which of the following is incorrect about a satellite? Correct answer is it suffers an acceleration. A satellite is a freely falling body. It does not require energy for its motion when it is in orbit, and its speed is constant. To understand this, try to remember the Newton's laws, especially about inertia, which states that every body will try to be in a uniform state of motion unless and until an unequal force is applied. What is the relation between the orbital velocity and the radius of the orbit for a given planet? Correct answer is A. For a given planet, greater the radius of orbit, lesser will be the orbital velocity of the satellite. The orbital velocity depends on the mass of the central body and the radius of its orbit. By how much times the orbital speed of a satellite needs to be increased to make it escape the gravitational field? It is better if you remember this objective data. Answer is D. It means that if the speed of a satellite orbiting close to the Earth is made root 2 times or increased by 41%, then it will escape from the gravitational field. To understand this, you can also compare the circular orbital velocity as well as the escape velocity. If you look at both the formulas, you'll understand that if our spacecraft is in circular orbit around any planet and we have to multiply our speed by a factor of root 2 to escape to infinity, regardless of the planet's mass. An Earth satellite S has an orbit radius which is 2 times that of a communication satellite C. What will be the period of revolution of S? Yeah, the answer is C, 4 days. As per Kepler's third law, the square of the period of any planet is proportional to the cube of the semi-major axis of its orbit. So when you put this in terms of ratios, you get what is the orbital velocity of a geostationary satellite? Correct answer is C, 3.08 kilometers per second. And orbital velocity of a geostationary satellite can again be calculated as root 2 capital G capital M upon R. Which of these represent the angular momentum of a satellite? Correct answer is A. Angular momentum of a satellite is given by mvr, and this angular momentum of satellite depends on both the mass of orbiting and central body as well as the radius of its orbit. Which of these statements is correct about the energy of a satellite? Correct answer is A. Potential energy of a satellite can be given by this formula as well as a kinetic energy. When you compare both, you get potential energy is equal to negative 2 times kinetic energy. What is the effect of increase in radius of orbit on the binding energy of a satellite? Correct answer is B, it decreases. The binding energy of a satellite decreases with the increase in the radius of its orbit, which means binding energy of a satellite is inversely proportional to the radius of the orbit. If the time of revolution is t in a satellite, then kinetic energy is proportional to which of the following? Again, if you consider this, the square of the period of any planet is proportional to the cube of the semi-major axis of its orbit. We have already seen this. So, r is inversely proportional to the cube root of the square of t. Hence, the answer is Ke is directly proportional to t raised to minus 2 upon 3. What will be the total energy of a satellite moving around the Earth in a circular orbit with speed v having mass m? Correct answer is D, minus 1 upon 2 mv square. Why? Because total energy equals negative kinetic energy. Formula of kinetic energy is 1 upon 2 mv square. By how much the orbital velocity of Moon has to increase for it to cease to remain the Earth's satellite? Correct answer is C, root 2 times. We have already seen this in our previous question. What is the escape velocity of a planet having mass 6 times and radius 2 times as that of the Earth? Here, the answer will be C, root 3 VE. To understand this, you will have to refer to the right hand side image. Escape velocity of a satellite is given by VE square root 2 gm upon r. So when m is 6 times and r is equal to 2r, then VE becomes root 3 VE. What will happen to a ball if it is dropped from a spacecraft revolving around the Earth at a height of 120 kilometers? Correct answer is D. So if a ball is dropped from a spacecraft revolving around the Earth at a height of 120 km, it will continue to move with velocity v along the original orbit of spacecraft, as the ball possesses same initial tangential speed as that of the spacecraft. So it also feels the condition of weightlessness. The distance of Neptune and Saturn from Sun are nearly 10 raised to 13 and 10 raised to 12 meters respectively. Assuming that they move in circular orbits, what will be the ratio of their periodic times? Here, looking at the formula, we'll get the answer as B, 10 root 10. Again, here we are using the Kepler's third law. If you have any doubts, feel free to comment. Thank you and see you in the next one.